everyone, welcome to my channel. In this video, I am going to solve another question from JAM 2021 Biotechnology paper. As you all know, in my channel, you can get guidance for JAM Biotechnology exam for next year. I solve PYQs and important topics for these exams. But have you ever thought what will happen if you don't qualify IIT JAM? There you have to think for the common university exams, right? So here Unacademy brings for you free special online classes. These classes are purely interactive live classes. You can see here TU or BHU classes are held every Monday and Thursday 10 am onwards. CUCET or JNU classes every Tuesday and Friday 10 am onwards. You can also take online mock tests. CUCET mocks are alternate Monday 8th and 22nd March 2021 9 am to 11 am. DU mock tests are alternate Monday 15th and 29th March 2021 9 am to 11 am. BHU mock tests are alternate Wednesday 10th and 24th March 2021 9 am to 11 am. HCU mock tests are alternate Wednesday 17th and 31st March 2021 9 am to 11 am. And the best part of these classes or mock tests is that these are absolutely free. And you can see here that not only biotechnology, whoever among you are from biotechnology background, you can have these classes. Also, if you are from physics or chemistry or math background, you can also take these classes. Okay, and to unlock these classes or tests, you can use the code IIT JAM 10 and you can enroll. As I said before, you can enroll for free because these are Unacademy special classes. For plus classes, you can also subscribe to plus classes in Unacademy. For 10% discount, you can also use my code PHYSJAM-570. I'm repeating PHYSJAM-570. You can use my code for 10% discount. Okay. So let's go back to our question. So this question is from Projectile Motion. Many of you this year can find this question a little tough, but let's see if it is tough or easy. So here the question is, a stationary enemy ship is docked in the sea at a distance of 1.0 km from the coastline. A gun located at the sea level on the coastline can fire projectiles at a velocity of 120 meters per second. What is the angle in degrees above the horizontal at which the gun must fire to hit the ship? Given is G equal 9.8 meter per second square. Option A is 21.4, option B is 42.9, option C is 23.6, option D is 47.1. Okay, so let's solve it. So suppose here is a ship, okay, which is at a distance of, suppose, R from the coastline. Okay, and given is R equal 1.0 kilometer. See here is the stationary enemy ship, okay, in this position, and it is at a distance 1.0 kilometer from coastline. Okay, so R is given as 1.0 kilometer, right? Now, a gun is located at the sea level on the coastline. Okay, so suppose here is the gun. Okay, suppose here is the gun. So from here, the gun fires projectiles at a velocity of 120 meter per second. Okay, so the projectile goes like this and it hits the ship here. Okay, so here the velocity of projectile is suppose u. So u is given as 120 meter per second. So this is the initial velocity of projection. So it is u equal 120 meter per second. So we can say that this is the velocity of projection, u equal 120 meter per second. Okay, now we need to find what is the angle above the horizontal. Okay, so we need to find the angle. So see, this is the horizontal, right? And this is the direction of motion of the projectile, right? This is the direction of motion of projectile and this is the horizontal. So this is the angle in between them, that is theta, and we need to find this theta. Okay, and again given is this g, that is 9.8 meter per second square. So g is given as 9.8 meter per second square. Now what is the formula for finding this angle? We need to use the formula for horizontal range of projection, that is R equal u square sine 2 theta by g. So this is absolutely a formula based question. If you can simply remember this formula, then you can simply and easily solve this question or this type of questions. Okay, so R here is the horizontal range. And what is the horizontal range of projection? Horizontal range is the distance from the point of projection, that is from here. Okay, let us call it as point A, to the point of hitting the ground or hitting the ship. Okay, so let us call this point as B. So the distance between point A and point B is called the horizontal range and denoted by R. So R is equal u square sine 2 theta by g, and from here we can write sine 2 theta equal g r by u square. So from here you can see that we know g, we know r, we know u. So from here we can calculate sine 2 theta, and from that we can calculate 2 theta, and from there we can calculate this theta, okay, which we need. So let's do that. So sine 2 theta equal g r by u square, right? So let us put the values for them. So g equal 9.8 into r is 1 kilometer. Okay, 1.0 kilometer. Now see here, u is in meter per second, g is in meter per second square, but r is in kilometer. Meter is SI unit, right? So we need to convert this kilometer to SI unit, that is to meter. So 1 kilometer equal 1000 meter, right? So let us put r equal 1000 meter here. So 1000 divided by u square. U here is 120 meter per second. So 120 square. Okay. So let us first calculate it. So 9.8 into 1000 by 120 square. Let us see what we get in our calculator. 9.8 into 1000 is 9800 divided by 120 square. So we get it as 0.68 approx. Okay, this is the approximate value, 0.68. Okay, so from here we can say that 2 theta equal sine inverse 0.68, right? So if we take the inverse of it, let's see what we get. We get it as 42.84. Okay, this is 2 theta, 42.84, but we need theta. We need theta, that is the angle of projection, right? So theta equal, if 2 theta equal 42.84, then theta equal half of 42.84, right? That is equal 21.42, or we can write it as 21.4 degree, right? So here the correct answer is option A, 21.4. Okay, so I hope you could understand this solution. If you have any doubt regarding this solution, you can tell me in the comment section. If you like this video, please click on the like button, share this video with your friends and help them in their studies. And if you are a new viewer today, then don't forget to subscribe our channel. Ta-da!